Hi guys, welcome to the session. Let everyone join and then we'll sort of get started. Okay. Just a moment. Let everyone root in. Hi Mukta Prava. I hope you're doing good. Just one question in the beginning. Have you attended the previous sessions on vectors or 3D? 3D, this is the only session which we are taking. One more session which we'll be taking in lesson the next Friday on 3D. Hello everyone. Welcome to the session, guys. Every one of you. So now most of us joined. Let's get started with it. Now, three-dimensional geometry, as I stated when we started with your vectors, that 3D geometry is also a very important part of your JEE syllabus or preparation. Right? It's okay, Tabish. So now over here, if I talk about JEE mains, you have around 2 to 3 questions in 3D geometry related to it, and similarly JEE advanced, you have at least 2 questions on three-dimensional geometry. Now, why is it so? Because 3D geometry involves the concepts of vectors in itself. That's why we picked up vectors in the previous class, and I hope all of you have seen those sessions. If not, please refer to them so as to understand the concept of vectors and the important questions related to vectors. Okay, let's get started with the three-dimensional geometry bit. So I'll first of all revise a few important terms. Today we'll talk about just lines. We'll talk about few important concepts which we need to remember with respect to lines, and then we'll see a few questions which have come in JEE earlier. You know that there are two forms of equation of line, one vector form, one Cartesian form. So this is how we write the vector form over here. This is how we write down the vector form over here. Pranav, I just told it is 2 to 3 in JEE mains and at least 2 in JEE advanced. So over here, this A is called as, this A over here is any point on the line, This is the position vector is A, and this vector B over here is a vector parallel to the given line, So this is how the lines equation is being made. If I know these two conditions, I can write the equation in this form. Similarly, I can express the same vector form into Cartesian form also, like this: x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. So this implies that the line is passing through x1, y1, z1, this point A, and the drs of the line is a, b, and c. These are the drs of the line. If a square plus b square plus c square is equal to 1, they can also be representing the direction cosines, DCs. So this is a very basic bit. If I talk about two lines, if I talk about these two lines, I've considered the two lines. Over here, I can say that line L1 passes through this point, which is written as x1, y1, z1, and L2 passes from this point, which is x2, y2, z2. And this first line is parallel to this vector B1. In order to write the corresponding vector equation, we can use these two vectors very easily. So B1, I'm just putting it as A1, B1, C1, I cap, J cap, K cap. Similarly, this second line is parallel to this vector over here, which is a very simple thing. Now, two lines can interact amongst each other in two ways in a three-dimensional plane or a three-dimensional space. How? They can either be coplanar. The lines could either be coplanar or they can be non-coplanar. If the lines are coplanar, then they can either be parallel lines. Either they can be parallel lines like this, they will be coplanar, or they can be intersecting lines like this. Still, they will be coplanar in either of the situations, right? If they are non-coplanar, they are called as skew lines. Skew lines imply the lines sort of like this, which are neither parallel nor intersecting, lines. So if I want to find out the conditions based on which I can predict whether the line is a parallel line, intersecting line, or skew line, let's have a look. From 12th, Anishri, come on. Okay, when the lines are parallel if they are parallel to the same vector or parallel vectors. When the vectors are parallel, when the corresponding corresponding values of A1, A2, B1, B2, C1, C2 are in proportion, right? So over here we will say A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Whenever this is the case, the lines are parallel, hence we can say that they are coplanar. Or we can say A1 is equal to A2. If I put it equal to some K, A2, so we can say A1 is equal to K times A2. If that is the case, and similarly, if this is the case with B1 also, B2 also, C1 also. So this, if this is equal to this, and this is also equal to this, then we can say that the lines are parallel to each other. When the lines will be intersecting, simple, the lines will be intersecting or the lines will be coplanar. If I talk about the coplanarity of the lines, so the lines are parallel, we can check it from here. The lines are intersecting lines, they will also be coplanar lines. So they can be intersecting when, if I choose the points which I've represented, let's say this point was A1, this point is A2, points A1 and A2 I've mentioned over here already, the points from which these two lines pass, and it is parallel to these two vectors. So let me make them as well. So this is vector B1 and this is vector B2. So what we can say that these lines will be intersecting or they will be coplanar if these three vectors or the scalar triple product of these three vectors. What is the third vector? If I join A1 and A2. So if I talk about this, if I say that these three vectors will be coplanar if their scalar triple product is equal to 0. This is the concept of your basic vectors. So what can we say? A2 minus A1, this vector, A2 minus A1, whatever the points are, and B1 and B2. If the scalar triple product of these three vectors turns out to be equal to 0, then we can say that the given three vectors fall in the same plane. If they fall in the same plane, we can very easily guarantee that they are coplanar. If I just quickly expand it to get a normal Cartesian form, so A2 minus A1 can be written as X2 minus X1, the scalar triple product. Then Y2 minus Y1, Z2 minus Z1. And B1 and B2 have their own corresponding values as ABC, A1, B1, C1, and A2, B2, C2. This is how we expand the scalar triple product. So this bit, if this is equal to 0, then we say the lines are intersecting. Now over here, you can just simply figure out this as one of the conditions to check whether the lines are coplanar or not. Why? Because if these numbers are in proportion, if these DRs of the lines are in proportion, in that case, A2 can be replaced by, A1 can be replaced by KA2 over here, KB2 and KC2. You can take K common, then these two rows will become the same. As soon as the two rows of a determinant is same, we get the result equal to 0. So this is how you can sort of remember that this is the only condition which will help us to determine whether the lines are coplanar or not. Parallel or non-parallel, that is intersecting, can be differentiated based on this condition. If this is true, then the lines will be parallel. If this is not true, and this bit is true, in that case, we'll say that the lines are intersecting lines. However, they are coplanar. If I talk about skewed lines, obviously this must not be equal to 0. That will be the first condition. And then the question talks about the distance between the lines. That's one very frequent question which you get, distance between the lines. So if I take these 2 points over here also, point A1 and point A2, obviously this one is parallel to B1 and this one is parallel to B2. So what we can say is if I join these 2 points and I project this vector on its perpendicular. So this is the perpendicular vector to both the lines. So you can say that the perpendicular vector to both the lines will be B1 cross B2. B1 cross B2 will be the perpendicular vector to both the given lines, perpendicular to their planes respective. So now what we can say is that if I project this A2 minus A1 on this vector, our purpose is solved. Projection of A2 minus A1 on this is written as what? A2 minus A1 vector dot unit vector of B1 cross B2. Unit vector implies we'll divide it by its coefficient. So this is said to be the formula to calculate the distance between skewed lines. This is the distance between skew lines. I hope this is fine. We'll apply this formula in few questions which we'll solve today. Let's see few JEE questions. The very first question in 2004, a single mark question. The question was very direct. It says if these two lines intersect, then the value of k is what? Now, if you know that if these two lines intersect, what happens? The scalar triple product or that determinant must be equal to 0. Determinant is formed by what? The difference between the coordinates over here. So in this case, the difference is 3 minus 1. In this case, it is k plus 1. And over here, z minus 0. So 0 minus 1, which is minus 1 itself. In the second row, you can choose any one of the drs of any one of the lines. In the third row, the other lines drs. You will solve this, you will get the value of k. If I just quickly solve it, this is 2, k plus 1. This is minus k, 2, 3, 4, 1, 2, 1. So we can expand it quickly. It's 3 minus 8, which is 5, to 10. So it is minus 10. Then negative of k plus 1. This turns out to be 2 minus 4, which is plus minus 2. So it is plus 2. And this turns out to be 4 minus 3, which is 1 with a negative 1. So you get a negative 1 over here. So k plus 1 turns out to be what? 11 by 2. Or this implies k turns out to be 11 by 2 minus 1, which is 9 by 2. The value of k turns out to be 9 by 2, which is quite simple to apply because the question was very direct. The question again repeated in 2012. Same question, only the equations were different. The lines this and this are coplanar. This time the question is saying that these two are coplanar. Again, you can apply the same stuff. You will get your answer. You will take the difference between the two. So 1 minus 2. 1 minus 2 gives me negative 1. 4 minus 3 gives me 1. 5 minus 4 gives me 1. Similarly, over here, 1, 1 and minus k. Over here, k2 and 1. You will solve this. This will give you a quadratic equation once you will solve. With the determinant greater than 0. With determinant greater than, sorry, discriminant, not determinant. With discriminant greater than 0. So this quadratic equation with the discriminant greater than 0 will have exactly two values. Right? So this is how we can sort of solve this question. I hope it is clear to everyone. If I show you a similar question, look, you have a similar question in JEE Advanced 2013 as well. What the question says, two lines, this and this are coplanar, then the value of alpha is what? Over here, the only twist was that the lines given to you were not in the exact form as you usually get them. So do understand how to convert these lines into the general form which we know. So over here, we write this as x is equal to 5 as x minus 5 upon 0. X minus 5 upon 0 is equal to y upon 3 minus alpha is equal to z upon minus 2. This is the first line L1. So over here, the DRs are 0, 3 minus alpha and minus 2. And the second line similarly can be written as this is x minus alpha upon 0. So just shift the alpha on the other part. In the denominator, put a 0. So that whenever you equate it to k, value of x always remains equal to 5. It doesn't change. If you relate it or equate it to some k2, the value of x relates or is equal to alpha only. It doesn't depend on k2. Now over here, in order to calculate the value of alpha, what to do? Same stuff, exactly the same thing. They will intersect if they are coplanar, or they will be coplanar if the determinant is equal to 0. The determinant says alpha minus 5. Alpha minus 5 over here, it is 0 minus 0. 0 minus 0 again. It is in fact simpler than the previous one, in fact. So 0, 3 minus alpha and minus 2. From here, you get 0, minus 1 and 2 minus alpha. This must be equal to 0. If you will solve it, it's a very direct stuff. What will you get? Alpha minus 5 is in one of the brackets. In the second bracket, these two things will be multiplied. 3 minus alpha, 2 minus alpha. Negative of 2 into 1, which is 2. This must be equal to 0. So it is alpha minus 5 times, if I open this bracket up, alpha square minus 5 alpha plus 6 minus 2 is equal to 0. We just need to solve it. We need to figure out the corresponding values of alpha. So alpha minus 5, we don't have to find out the total number of values. Total number of values possible could be easily predicted. Over here, you can break it into two parts, alpha minus 4 and alpha minus 1. This is how you can sort of factorize it. You get the value of alpha as 1, 4, and 5. From the options, 1 and 4 are the only options possible over here. So 1 and 4, A and D will be the answer to the question. So JEE Advanced, a direct question on what? Just this determinant. You must know this. And I've shown you many questions, and there are many other questions also which have appeared in JEE paper regarding the same concept. So kindly understand and follow the concept, right? This is also a very common question, at least in JEE mains. JEE main, this is a very common question. What the question says, the distance of this point from the plane measured along the line this. So at times we know the formula to calculate the distance of a point from a plane. If I talk about the perpendicular distance, there is a direct formula, you will apply it, you will get the answer. However, if the question is that there is a plane over here and there is a point somewhere here, so this point is 1 comma minus 5 comma 9 given to us, and the equation of the plane is x minus 5 plus z is equal to 5. Now you need to measure it along x is equal to y is equal to z. So for instance, x is equal to y is equal to z is a line like this. So we need to kind of make a parallel direction over here, same direction, in the same direction as it is, and then we'll get the point of intersection. So if I'm saying this point is P, we'll get a point Q. We need to calculate the distance PQ. This is what the question is asking for. So the simplest way to go about it is, you know that the drs of this line will be what? Drs of this line can be written very easily when is 1 comma 1 comma 1. Why? Because x upon 1, y upon 1, z upon 1. So basically drs of this line will also be the same, 1 comma 1 comma 1, or maybe proportional to it. So we can choose any one of the values, 1 comma 1 comma 1. So we can figure out the equation of PQ. So we can write PQ as x minus 1 upon 1, y plus 5 upon 1, and z minus 9 upon 1, which can be equated to some lambda, right? So you can get the coordinates, parametric coordinates of Q. Parametric coordinates of Q can be written as lambda plus 1, comma, lambda minus 5, lambda plus 9. And then you know that it lies on this plane, so it will satisfy this equation. Place it over there, you will get your answer. So x plus lambda plus 1 minus lambda minus 5, sorry, plus 5, plus lambda minus lambda plus 9 is equal to 5. You need to solve for the value of lambda. This and this gets cancelled out, isn't it? Yeah. And lambda turns out to be what? 5 also gets cancelled out. Lambda turns out to be minus 10. What you need to find out, you need to find out the distance. You need to find PQ. As of now, we have just figured out what is Q. We have just figured out what is Q. Q is minus 9 comma minus 15 comma minus 1, right? So the distance between P and Q will be what? If I sort of do it over here only. So distance between PQ is the difference between these two. So 9 minus 9 minus 1 is 10 squared. 15 minus 5, 10 square again. And 9 plus 1, 10 square again. The answer to the question is 10 root 3. B is the answer to the question. A very simple question. Now see, mains 2016. Mains 2017, same question. The question says if the image of the point this in the plane this measured parallel to this line is Q, then PQ is equal to what? Right? Again, the question is talking about a same concept. It is saying that this is a plane, x upon 1, y upon 4. Sorry, this is the line. The plane is given to us as 2x plus 3y minus 4z plus 22 is equal to 0. You know a point over here P, 1 comma minus 2 comma 3. Now over here you need to find the image of this point P. One image concept says that this will be the image Q. However, over here the question says that it should be along this line. You will say if it is along this line, it will be somewhere here. This is the image. Let's say the image is I. So this will be the image. This is point Q and this is the image. So again, the question basically is talking about the same bit. The line which has DRs 1, 4, and 5, you're going to be constructing the parallel line from which you will be able to get the value of Q. Calculate distance PQ. That will not be the answer. The answer will be PI. So double of PQ, you will get PI. I hope most of you will be able to calculate this answer as well. It's a very, very simple thing. You need to apply the same strategy to get down to the answer to this question. So make yourself very comfortable in all such questions. Let's try a paragraph type question. This is a question in 2018, 12 mark questions. It consists of 3 parts. I'll solve all the parts. Each part consists of 4 marks. Read the following passage and answer the question. Consider the lines this and this. There are 2 lines given to us. Line 1 passes from -1 comma -2 comma -1, DRs are 3 1 and 2. Line 2 passes from 2 comma -2 comma 3, and the DRs are 1 2 and 3. The distance of the point this from the plane passing through the point this, and whose normal is perpendicular to both the lines L1 and L2 is what? Yes, Ranjit. The distance of this point from the plane passing through the point this, whose normal is perpendicular to the both lines. Okay, so any vector that is perpendicular to both the lines will simply be the cross product of their parallel vectors. So we'll say normal whose normal is perpendicular to both the lines this and this. Normal is b1 cross b2. b1 cross b2. This is the normal vector. What is b1? b1 over here is 3i plus j plus 2k. The DRs of this line L1. What is b2? b2 is I plus 2j plus 3k. Right. So you'll figure out the normal first of all, b1 cross b2, which is very easy to figure it out. You'll place in these values. This is how we find out the cross product 1, 2, and 3. If you see it, 3 minus 4 gives me negative I. 3 minus 2, 9 minus 2 gives me 7. And with a negative sign, so minus 7j, and 6 minus 1, 5. So plus 5k. This is what the normal vector to that plane would be. We need to figure out the distance of this point from that plane. Now the plane passes from this, whose normal vector is this. If you know the point from which the plane passes, through what? -1, -2, and -1. And normal vector is what? So these are the DRs basically. Minus 7j plus 5k. So DRs of normal is -1, -7, and 5, and this is the point. Therefore, the equation of the plane can be written very easily. Equation of plane will be -1 times x minus of -1, which is x plus 1, -7 times y plus 2, plus 5 times, plus 5 came from here. This is z minus of -1, which is z plus 1 is equal to 0. This will be the equation of the plane. If you'll write it properly, take the negative sign, take it common. So this will turn out to be plus, this will turn out to be plus, and this will turn out to be minus. If I just quickly change it, this turns out to be negative. So over here, x plus 7y minus 5z. Then 14, 15 minus 5 gives me a 10 is equal to 0. This is the equation of the plane. Now we don't have to calculate the equation of the plane. We need to calculate the distance of this point from that plane. So by applying the distance formula, I hope you know, we place in the equations, or the point over here in the equation, 1 comma 1 comma 1, and we divide it by the square root of the squares of these coefficients. So let's say 1 plus 7 minus 5 plus 10 mod of it divided by 1 square plus 7 square plus of minus 5 square, which is 5 square only. We have already done that, Pranav. Have a look on all the previous sessions as well. So this turns out to be what? 5, 13 upon this is what? 49, 50, 25, square root of 75. 13 upon square root of 75 is the distance. 13 upon root 75. C is the answer to the question. Hopefully, everyone is clear with what or how to do this question. This was the JEE advanced question, you may say, because it was a paragraph-based question. The second part to the same question is this: shortest distance between L1 and L2. If at all you remember, I told you that the shortest distance is what? The shortest distance between the skewed lines is A2 minus A1 dot B1 cross B2, the unit vector of it. That's it. A1 and A2, the difference between them can be figured out very easily from here. So in this case, what we can do is A2 minus A1, we can calculate very easily. So if I take the difference, 2 minus of -1, which is 2 plus 1, that is 3i Then minus 2 will get cancelled out 0. And then 3 minus of minus 1, which is 4j. Right? So 3i plus 4j is a2 minus a1. b1 cross b2 we have already calculated. So let me copy it from the previous one. b1 cross b2 we calculated is minus I minus 7 plus 5. Minus I minus 7j plus 5k. We have already calculated that. Therefore, the distance between them is. So the first question was the only question wherein the challenge was a bit of challenge. That's it. So the distance between these two skewed lines will be what? That'll be the dot product between the two. So 3 into minus 1 plus 0, obviously into minus 7 plus 4 into 5 divided by the magnitude of this vector. Magnitude of this vector will be what? 1 square plus 7 square plus 5 square. So this turns out to be what? This is basically 0. 20 minus 3 gives me 17 upon square root of 75. Square root of 75 is 5 root 5. So 17 upon 5 root 3, sorry, 5 root 3. So D turns out to be the answer to this question. Last question on the same paragraph was unit vector perpendicular to both L1 and L2, which we figured out in the very beginning. We figured out the vector perpendicular, B1 cross B2 we already figured out. That was minus I. By now you would have sort of learned it because you've used in both the questions. Plus 5k. We'll divide it by its magnitude, which we know was root 75. Root 75. So without actually writing anything, you know what the answer to the question would be for the third part, if you're clear with the first two parts. So B turns out to be the answer to this question. Hopefully this makes sense to all of us, whatever we discussed today. Hope you enjoyed the session as well and you learned a bit. At least now you are clear with how to differentiate between the lines that are coplanar, the lines that are non-coplanar, and how to figure out the distance between two lines. Also, you are clear how to figure out any point that is parallel to a certain line, or how to figure out the image of a point parallel to a given line. Fine, guys. So let's call it a day. The next session on 3D will happen on Friday. Maybe the times would change. You will be intimated about it. As of now, we'll say that it will happen on Friday, 4:30. So I hope you're going to come over there. Fine, guys. So till then, take care. Have fun. Good night. And see you guys in the other session. Bye and have fun.